While the world focuses on the unpredictable eruptions of Yellowstone, a far more immediate threat lurks beneath the Pacific waves near the United States. Recent seismic reports are alarming. The region's underground tremors have soared to a staggering 500 quakes daily, signals indicating the imminent awakening of a volcano capable of global catastrophe. After 3 decades of monitoring, scientists now predict, with remarkable accuracy, that a disaster of planetary proportions could strike within the next 2 years. This submerged volcano exhibits unmistakable signs of an impending eruption. The seafloor is rising rapidly, at a rate of 25 centimeters annually, which is 10 times faster than the average, underscoring the urgency. Experts concur that a major volcanic event could occur by the end of 2025. Such an eruption would be unprecedented in human history, as it would be the first time a colossal underwater volcano has been observed erupting in real time. What makes this threat even more unsettling is that it has long been underestimated. For decades, authorities and scientists ignored it, perceiving it as an invisible risk overshadowed by more visible giants on land. Meanwhile, the true danger has been quietly brewing below the surface, where the least attention is paid. This underwater menace lies just off the U.S. coast, raising questions about its potential impact and the broader regional consequences if it fully awakens. The volcano in question is known as Axial, hidden beneath the Juan de Fuca Plate about 480 kilometers west of Oregon. Sitting at a depth of approximately 1,410 meters, with a height close to 700 meters, Axial has formed a rectangular caldera measuring 3 by 8 kilometers, surrounded by rift zones. Discovered only in 1983 around hydrothermal vents caused by its underlying activity, Axial remained largely unnoticed because it is submerged in darkness. Unlike terrestrial volcanoes that roar with flames and spewing ash, this oceanic giant works silently beneath the waves. Its potential is shocking, especially considering its unique geological setting. It straddles a mantle hotspot and a segment of the oceanic ridge, an extremely rare combination. This intersection makes Axial a genuine hotspot in the literal sense of the term. According to Professor William Wilcock from the University of Washington, such volcanoes are the most concerning to scientists. The caldera of Axial functions as a hydrothermal system, with waters heated to over 500 degrees Celsius. Hidden beneath the ocean's surface, this volcano exemplifies nature's remote yet ominous threats, reminding us that beneath calm waters can lie the most destructive forces waiting to emerge. One of the most extreme environments on Earth, the waters surrounding the Axial volcano, can reach boiling temperature in mysterious and unpredictable ways. Yet, more importantly, Axial is preparing to reveal its true power, according to scientists' warnings. Over the past 30 years, the volcano has erupted exactly 3 times, with mathematical precision. These eruptions occurred in 1998, 2001, and 2015. And if volcanic activity could be scheduled like trains, Axial might have earned accolades for punctuality. Every 7 to 8 years, it seems to sound an underground alarm, reminding the world of its formidable presence with a powerful underwater explosion. For enthusiasts interested in such phenomena, it's worth noting that a dedicated Telegram channel exists, where content not suitable for YouTube, like satellite images, insider insights from analysts, and reports on strange, dangerous events, is regularly shared. These materials provoke reflection on what is happening beneath the ocean's surface. The link to join can be found in the description and the pinned comment. In 2015, a breakthrough in volcanology occurred when a team of biophysicists from Oregon State University accurately predicted Axial's underwater eruption for the first time in history. Prior to each eruption, the volcano inflates like a balloon, a process known as volcanic inflation, occurring at remarkably regular intervals in this case. To study this phenomenon, scientists dispatched a research vessel in 2019 that conducted a comprehensive three-dimensional scan of the undersea giant, confirming their expectations. The last eruptions in 2015 were truly spectacular, even if invisible to the naked eye. Over a 24-hour span, scientists recorded about 10,000 minor earthquakes beneath the sea. Magma flowed from the volcano for a month, stretching approximately 40 kilometers along the seafloor, which itself was pushed upward by about 2.5 meters, like a giant air mattress deflating. Interestingly, all three recent eruptions happened between January and April, when the Earth is farthest from the Sun. Today, Axial exhibits several signs indicating it may be gearing up for another large eruption. Scientists continuously monitor this process in real time, akin to doctors tracking a patient's vital signs. In November of 2023, geophysicist William Chadwick observed the volcano's surface swelling nearly to the levels recorded before the 1998 eruption, raising initial concerns. Yet the true alarm sounded later, especially from January 2024 onward, as both the volcano's swelling and seismic activity accelerated alarmingly. By July of last year, the rate of inflation reached 25 centimeters annually, that is, 10 times faster than normal. Previously, the region experienced several dozen earthquakes daily. Now, this number has surged to hundreds each day. Sometimes, seismic activity exceeds 500 tremors every 24 hours, effectively meaning an earthquake occurs under the water every 3 minutes without pause or rest. To track this relentless activity, a special underwater observation service has been established, functioning as a dedicated deep-sea observatory focused solely on monitoring Axial's restless behavior. The network of sensors, interconnected by extensive fiber optic cables, transmits real-time data about volcanic activity. Advances in technology now enable not only monitoring traditional eruption signs, but also deploying artificial intelligence to analyze seismic patterns with unprecedented precision. These sophisticated algorithms compare current data with those from the Tisici eruption, revealing alarming signals. All indicators suggest that an eruption could occur within any moment between now and the conclusion of 2025. When it finally awakens, this event will have planetary implications. As magma pierces through the ocean floor, water temperatures at the eruption site will instantly soar to 1,200 degrees Celsius, 3 times hotter than the melting point of copper, triggering powerful explosive bursts that can be heard dozens of kilometers away. The Tisici Huang Tongo earthquake, which saw an underwater volcano release 150 million tons of water vapor into the stratosphere, was merely a rehearsal for the colossal drama deep beneath the waves. That eruption propelled steam as high as 55 kilometers, 3 times higher than commercial airplanes fly. If the dormant volcano reawakens, its immense energy could unleash catastrophic waves, impacting the lives of around 1.5 billion people across 23 nations. Recent geophysical data indicate that such an eruption will trigger a cascade of climate anomalies capable of altering the Earth's ecological map for months. The Federal Emergency Management Agency has presented startling estimates. A submarine eruption reaching a magnitude of 9 could generate a tsunami up to 30 meters high. These deadly walls of water would reach Oregon, Washington, and Northern California within just 15 to 20 minutes of the eruption. In the United States, the Pacific coast would face a disaster at a first-level emergency scale. Cities from Alaska to California are expected to be devastated. A city like Seattle, with 750,000 residents, could face a 15-meter tsunami wave merely 18 minutes after the volcanic eruption. Portland, home to around 650,000 people, might be cut off from rescue efforts for weeks. All bridges over the Columbia River could be destroyed by water surges rising 20 meters high. San Francisco, California's economic hub with a 7 million strong population, would confront a dual catastrophe. Initial flooding from the tsunami, followed by seismic activity along the San Andreas Fault, potentially culminating in earthquakes reaching strength levels of 8.5. Silicon Valley, where nearly 40% of the world's technological innovations are concentrated, could remain incapacitated for months. To the north, Canada will not be spared. Vancouver faces a 12-meter tsunami within 22 minutes of the eruption. Thunder Bay, the largest port in Canada and fourth in North America, could be entirely leveled, disrupting exports of grain and triggering immediate fluctuations in global food markets. Despite being 8,000 kilometers away, Japan faces imminent catastrophe, as recent volcanic eruption lessons from Juan have demonstrated. Underwater eruptions powerful enough to generate destructive tsunamis can send waves racing across the entire Pacific Ocean, carrying devastation to distant shores. Along the southeastern coast of Kyushu, waves reaching 3 to 5 meters could trigger the evacuation of 5 million residents and force the shutdown of 15 nuclear power plants. The economic fallout for Japan would be devastating, with key ports like Tokyo, Yokohama, and Asuki's infamously busy harbors, responsible for over half of the nation's exports, being closed for at least a week. Japan's automobile industry, which manufactures nearly 10 million vehicles annually, would come to a halt due to disrupted supply chains and logistical chaos. Meanwhile, the volcanic ash ejected into the stratosphere would block sunlight over East Asia for up to 3 years, causing regional temperatures to drop by 2 to 4 degrees and altering climate patterns on an unprecedented scale. In populous Chinese cities, a tsunami of 2 to 3 meters could flood coastal areas, inundating industrial zones and halting production that accounts for about 28% of the global gross domestic product. Meanwhile, South Korea faces a triple threat. Tsunamis between 4 and 6 meters would strike its ports of Pusan and Incheon, paralyzing the country's shipbuilding industry. Controlling roughly 35% of the worldwide market and critically affecting its semiconductor sector. The giants Samsung and SK Hynix, responsible for 60% of the world's digital memory, risk halting manufacturing due to energy shortages and logistical failures. In Australia and New Zealand, the climate crisis would deepen. Changes in ocean currents and disrupted monsoon patterns could induce severe droughts in eastern Australia, while New Zealand's economy, relying about 65% on agriculture, might face losses up to $30 billion because of unpredictable weather patterns. Across South America, the chain reaction would be felt through the butterfly effect. Chile, despite its distance, could experience tsunamis of 1 to 2 meters, leading to port closures and a halt in copper exports. This disruption would ripple through global markets for metals and electronics, affecting prices worldwide. In Colombia, markets for bananas and coffee, vital exports, would suffer as disrupted trade routes across the Pacific diminish sales. Russia, though ostensibly insulated, would face enormous losses. Ports like Vladivostok and Nakodka might endure 1 to 3 meter tsunamis, but the more severe blow would come from the collapse of global trade flows. Russian natural gas and grain exports through Pacific routes could decrease by nearly 80%, costing the national budget between 150 and $200 billion. Europe, although physically distant, would not escape unscathed. The continent could face a surge of climate refugees, estimating from 15 to 20 million, fleeing affected Asian regions, potentially sparking a humanitarian crisis 10 times larger than current migration events. Economically, the European Union could lose around 700 billion euros, exceeding the total GDP of both Panama and the Netherlands, primarily due to shattered trade links and economic uncertainty. Climate models indicate that an eruption rated at 8 points on the Volcano Severity Index could lower the Earth's temperature by 3 to 7 degrees Celsius for up to 5 years. Such a drastic cooling would likely cause agricultural collapse in the Northern Hemisphere, fueling mass migrations and triggering widespread social and economic upheaval. Underwater eruptions are unique in their dual ability to both cool and warm the planet simultaneously. Ash clouds in the stratosphere block sunlight, leading to cooling, while vast amounts of water vapor, measured in billions of tons, are injected into the atmosphere, intensifying the greenhouse effect for decades. This delicate balance underscores the complexity of volcanic influence on climate. The story of Earth's axis tilt is merely the tip of the iceberg in an immense underground realm that humanity is only beginning to explore. Currently, scientists have identified over 19,000 submarine volcanoes, although estimates suggest the real number could reach 1 million. In comparison, there are roughly 4,000 terrestrial volcanoes, including dormant ones. Underwater, volcanoes produce 12 to 15 times more lava, gases, and other volcanic materials than land-based volcanoes, constantly shaping and reshaping the seabed at astonishing speeds. Every day, multiple minor eruptions occur beneath the oceans that often go unnoticed. In January of 2022, the eruption of the Hunga Tonga volcano in the Pacific Ocean was among the most powerful in the past 3 decades. The sound waves from this eruption traveled up to 10,000 kilometers, further than the distance from Moscow to Vladivostok. The resulting waves circled the globe twice, and the shockwave completed 4 full rotations around the Earth. The economic damage from this event was estimated at about $90 billion, but what was more significant was the vast amount of water vapor released, adding a potent greenhouse gas to the atmosphere and potentially influencing global climate patterns. Remarkably, our knowledge of Mars's surface surpasses what we understand about the ocean floors, which remain mapped at only 25% of their area. Humanity's technological progress has enabled accurate weather forecasts weeks into the future, yet we remain largely powerless against underwater volcanoes that can alter the climate for years. Perhaps these submarine giants still hold surprises that will force scientists to revise geological doctrines. If you found this information intriguing, consider exploring further. It might just change your perspective on Earth's hidden, dynamic interior.